भंसारी सर स्टार्ट कर दीजिए 30 सेकंड के बाद।
Just one moment.
सर गजानन सर, हेलो हेलो।
Yes,
सर
yes, correct. Just one moment.
सर, आई एम ऑडिबल टू यू?
Yes, yes. You are audible. फक्त ते YouTube वर कसं मला दिसत नाही आलं.
ओके सर, तुमचं इंट्रोडक्शन मला पाठवता का थोडं या व्हॉट्सअपवरती? का तुम्ही करणार स्वतः?
हा, मी करतो ना, काही प्रॉब्लेम नाही. व्हॉट्सअपवर आता मला टाईप करावं लागेल ना सर?
अच्छा अच्छा अच्छा, बरं चालेल. हेलो विराट सर, विराट सर.
गुड आफ्टरनून. हा, वंजारी सर, ऐकू येत?
You can start sir now.
Start the session, sir.
Yes sir, you started.
Sir, we are already live. Please start the session, sir.
Okay. Okay, I hope I am audible and visible both. By the way, I'll make a small introduction about myself. I am Gajanan D. Pataskar. I am basically a mechanical engineer plus a cost accountant. I spent some 15 years in merchant navy. Thereafter, I did CMA, and nowadays I do give consultancy, and along with that, I have got my own coaching institute, Balaji Coaching Center, which is only for CMS. I think this much introduction is enough because we have very small time at our disposal. So let's start with operations management. Actually, paper number 9. It has got two parts: operations management and strategic management. Operation management is for 70 marks. I'll take care of these 70 marks. I hope you have a file, a Word file on which there are some examples. Yeah, do you have? I can't get any responses. Okay, so वंजारी सर, मुलांचे रिस्पॉन्स कसे घ्यायचे?
Sir, response will be come on YouTube only, sir. You have to check YouTube comment section.
Okay, but am I visible and audible to them? I have no idea. Because here only there is Manisha D. Hello.
Yes, Gajana sir, you are visible and audible.
But then see what happens is I'm not getting any response in the chat box.
No, not
So I
here.
need them badly.
YouTube comment section, sir. You have to go to YouTube.
I have been there. I have been there.
So there are comment is there, sir. Yes, sir. You are visible and audible, sir. Audible and visible to us. Yes, sir.
So you mean top chat, huh? Okay. So I could see few. Okay. Fine. So I'll start. So basically, what is operations management? Operations management is basically planning, scheduling, and control of activities that transform input into output. So basically, operations management is planning, scheduling, and control of activities that transform input into output. So what do you mean by input? Input means raw material plus labor plus overheads. Output means goods and services. So if you allow me to define it, or if you allow me to simplify it, I would say operations is synonymous with production. Actually, this term operation is a broader term, but you may say operation production plus quality control plus purchase, etc., etc. Now, if you see, we have inputs, raw material, labor, and overheads. These are what our inputs. And then we have goods and services. And this is where our production is, production or service. Now, if you look at these factors, you will realize that these are all resources we are talking about. So raw material means men. Sorry, labor means men. Raw material is a part of material. Then overheads could be depreciation. Then it could be insurance on machinery. So basically, this is about machines. So basically, we are talking about men, material, and machines. So these are all resources. And resources are not unlimited. Resources are not unlimited. That means we have to use them sensibly. In OM, in operations, we call it as optimum utilization of resources. In operations, we call it as optimum utilization of resources. Now, the question is how to use these resources, which are not unlimited, optimally. We have certain techniques, tools and techniques in operations. So what are these tools and techniques? So we have linear programming. We have transportation. So we have assignment. Then queuing, simulation, then EBQ, project management, then you have maintenance management, then we have replacement, works, measurement, and many more. So basically, let me take a recap of what I said so far. So basically, what is operations management? It is planning, scheduling, and control of activities that transform inputs into outputs. Now, inputs are raw material, labor, and overheads. Outputs are goods or services. So, roughly, operations means production, and you can add to that quality, purchase, etc., inventory management, etc. So, basically, if you see these inputs, raw material, labor, and overheads, you will find they are nothing but resources, men, material, machines, which are not unlimited. There are constraints. So that means we have to use these resources sensibly. In operations, we use a term which is called as optimum utilization of resources. Now the question comes to our mind that how to use these resources optimally. And then we have an answer in operations management. It says that you can use variety of tools and techniques like linear programming, transportation, assignment, queuing, simulation, EBQ, project management, maintenance management, replacement, work measurement. Then there is demand forecasting and likewise. So what we'll do, we'll take questions, numerical questions. Basically, they are important in operations. So what I will do, I will try to touch upon all these topics. We'll take one question each so that you will get a feel of operations management. So should we start? I hope you have the file with you. I'll just check the responses. Yes, Manjari sir.
Yes sir.
बस रिस्पॉन्स नहीं दिख रहे कभी.
रिस्पॉन्स
है ना सर, वो यूट्यूब में है, लाइव में.
हाँ, okay, okay. Now I can see that. Yes.
Right.
Okay, fine. Yes, yes. Now I can see that. Okay. So I hope you have the file with you where there are some 15 odd problems. Yes, Manjari sir. So here students are saying they haven't received any file.
है ना सर, वो यूट्यूब में है, लाइव में.
Okay. Now I can see that. Yes. Okay, fine. Yes, yes. No. My question to students is, I hope you have file with you where there are some 15 odd problems.
Sir, student already have the file. They are responding as well. Few students don't have, so they can check their mail where they have registered. In that, they received the at around 1:30 kind of or 1:20 mail.
Okay, fine. So I will start with the first question. All of you, please take problem number 10.
Sir, student already have the file. They are responding as well. Few students don't have, so they can check their mail where they have registered. In that, they received the at around 1:30 kind of. Sir, you can mute your mobile, sir. You have to, I think, read comment only, so that voice is not required, sir.
First question, all of you, please take problem number 10. So problem number 10.
Sir, you can mute your mobile, sir. You have to, I think, read comment only, so that voice is not required.
No, no, my mobile is on mute. My mobile is on mute mode. Okay, so let me. Okay, with the help of the following data, project the trend of sales for next 2 years. No, no, my mobile is on mute. So you have been given years: 2002, 2003, 2004, 2005, 2006, and 2007. Okay, so let me. Okay, so with the help of the following data, project the trend of sales for next 2 years. So you have been given years: 2002, 2003, 2004, 2005. Acha, okay. YouTube. Okay, so sales values are rupees 100 lakhs, rupees 110 lakhs, rupees 115 lakhs, 120 lakhs, 135 lakhs, and 140 lakhs. So let's start. Now this is called as demand forecasting. Now demand forecasting is also called as sales forecasting. So with the help of this particular tool, we can forecast sales. Once we have expected sales figures, we can always calculate expected production figures. So from expected production figures, we can calculate raw material consumption figures. From raw material consumption figures, we can calculate raw material purchases. Also, we can calculate direct labor hours. From direct labor hours, we can calculate direct labor costs. We can also calculate overhead absorbed. Based on expected production figures. But the origin lies in expected sales figures. So if we can calculate expected sales figures, we can calculate expected production figures. From there, we can calculate raw material consumption, raw material purchases, direct labor hours, direct labor cost, even overheads can be absorbed on the basis of production. So basically, it helps in preparing our budgets. So let's see how to tackle this problem, which appeared in one of the past examination. So I'll start with a trend equation. So I'll say let the trend equation be y is equal to a plus bt. And normal equations are summation y is equal to n into a plus b into summation t, and summation ty is equal to a summation t plus. Now these are called as, now these equations you have to learn by heart. Okay. Now see, what is t here? T is okay. I will explain you what is t, but for that we'll write the data in a particular manner. So here, then here, cells. Now here is x, cells y. So this is my independent variable, and this is dependent variable. Okay. So here is 2002, 2003, 2004, 2005, and 2006. And simultaneously I will write sales. So 100, 110, 115, 120, 135, and 140. Okay. Now see, I will define one more variable here, t, which is x. T is equal to x minus deviation from the midpoint of the time series. So t is x minus deviation from the midpoint of the time series. So my t will be x. Now look at this. How many observations are there? 6 observations. So number of observations are even. So midpoint is not automatic. Try to understand this. If number of observations were odd, then the midpoint would have been automatic. But now I have 6 years. So can 2004 be the midpoint? No. Can 2005 be the midpoint? No. So what we do, we take average of 2004 and 2005. So here it is, x is equal to 2004.5. But then if I use t is equal to x minus 2004.5, then I'll start getting all fractions. So what I do is I divide this by 0.5. Now see what happens. Here my t becomes what? So 2002 minus 2004.5 divided by 0.5. So what do you get? Can anyone answer that? Can anyone answer that? So can anyone answer that? So it is -5. Then this will be -3. This will be -1. This will be 1. This will be what? 3. And this is 5. Okay. Now let's have a look at the equations. Do we have summation y? Yes, we have summation y. Here it is. So what is summation y? Can someone tell me summation y? See, you are supposed to do these problems yourself and tell me the answers. Yeah, that's right. So here, this will be summation 120. Sorry, 720. Yes. So we have summation y. Correct. Okay. Do we have summation t? Yes, we have summation t. Here it is. Okay. So now let's talk about summation ty. I need summation ty. Summation ty will be what? -500 -330 -115, then 120, 405 and 700. So what is the summation? Summation t is equal to 0. See, there is a query from Rajesh Nayak. Sir, why we divide by 0.5? See, you can choose not to divide it by 0.5, but in that case, we'll start getting all fractional figures. I want to avoid fractional figures, Brajesh. Are you getting me? I want to avoid fractional figures. So I divide all the numbers by 0.5 and I'll start getting integers. So that's why. Okay. So now let's calculate. So this is over. Now summation t square. Summation t square will be what? 25, 9, 1, 1, 9 and 25. So this is summation t square, which is 70. Now I have everything what it takes to calculate the values of A and B. So putting above values in, let's call this as equation 1. in 1 and 2, we get 720 is equal to 6 into A plus B into 0. Therefore, 6A is equal to 720. Therefore, A is equal to 120. And 280 is equal to A into 0 plus B into 70. Therefore, 70B is equal to 280. Therefore, B is equal to 4. So putting values of A and B in the trend equation, we get y is equal to, which is y is equal to A plus bt, is it? So y is equal to A is 120, B is 4. Okay, so this is what the equation, trend equation. Now we have to calculate trend values or trend of sales for next 2 years. So actually, when X is equal to 2008, sales Y is equal to how much? But X is equal to 2008 means T is equal to what? According to our definition, X minus 204.5 divided by 0.5. So 2008 minus 2004.5 divided by 0.5. So this gives me 7. So let's put the value here. Y is equal to 120 plus 4 into 7, which is equal to 148. That is rupees 148 lakhs. Okay. Now there is one more question. When X is equal to 2009, so what happens now? Then T is equal to what? Again, we have to calculate sales. Y is equal to how much? So T is equal to 2009 minus 2004.5 divided by 0.5. So that gives me 9 this time. So Y is equal to 120 into 120 plus 4 into 9. So that is 156, which is equal to rupees 156 lakhs. Now for this, you will get 6 to 7 marks. Such a simple question, you should go and attack. So you will get a simple question like this in the exam for which you will get 6 to 7 marks. So let's take the next one. So I think there was some mistake in my calculations here. So actually I'm borrowing figures from some of you. So it may happen that the person I'm asking is giving me wrong answers. So it's your duty to correct me because I'm not calculating anything by myself. I think Sudhir, have you got it? Sudhir Shevokar. So I'm borrowing figures from you guys. So if I get a wrong figure, that will be reflected in my calculations. So it is your duty to calculate yourself and tell me if something is wrong there. Yeah. Is that clear? Please respond. Yes, there I can see the message of Mr. Sudhir. Sudhir, yes. Now that figure is corrected. Okay. So basically I'm taking figures from you. So I'm not calculating anything here. So what I suggest, if somebody gives me a wrong figure, you correct me immediately. See, it is an interactive session. I don't want to calculate everything myself. I want you to participate. You give me the figures and I will write them on the screen. And that is how we'll take all these problems one by one, of course. Chalo, I think you have got the method which I'm using. Fine. Now let's take problem number 2. Problem number 8. So this is what. Are you ready? Problem number 8. Okay, great. Now let me read the problem. Now I think we have got into a groove. Now hereafter, I think everyone will participate. See, participation is what the key to operations management, because your paper is full of practical problems. Of course, there is theory, but practical problem solving will help, and that is what I'm going to do for today and tomorrow. So let me read the question. Vision Graphics provides copy services for law firms in Mumbai suburbs. 5 customers submitted their orders at the beginning of the week. Specific scheduling data are as follows. So you have job A, B, C, D, processing time in days, due date days hence. So for A, processing time 3 days, due date 5 days hence. That means suppose today is 2nd of November, so due date is 7th of November. Okay. So for B, processing time is 4 and due date is 6 days hence. So due date will be 8th of November, and likewise C, it is 2 and 7, D it is 6 and 9, E it is 1 and 2. All orders require the use of the only color copy machine available. Vision Graphics would like to use the following priority rules and decide the best rule for job sequencing using the evaluation criteria of minimum flow time. So you have FCFS, first come first serve, SOT, shortest operation time, CEDD, earliest due date, STR, slack time remaining, and LCFS, last come first serve. So please read this problem once. See, Ananya, I have circulated one Word file. From there I am taking all these problems. So you read this problem once and then we'll see how to tackle it. Okay. I hope you have read the problem. Somebody please answer. Have you read the problem? Have you read the problem? Okay, great. Monica is saying yes, she has read the problem. Okay, great. Now, this is called as scheduling. Scheduling. Now, let's see what is scheduling. Scheduling means scheduling means production scheduling. Now, what do I mean by production scheduling? It means when a particular job is to be performed, when a particular operation is to be performed. So basically, you may say it is timetable for production. Now, proper scheduling helps in delivering the product on time, thereby avoiding delays. So, proper scheduling helps in delivering the product on time, thereby avoiding delays. Now, there are different techniques of production scheduling. What are they? First, it is priority rules. Then, second, it is critical ratio method. And third, it is Johnson's rule. Now, this problem number 2, is a falls under priority rules. That means our problem number 8. So problem number 8 falls under priority rules. So you see there all these priority rules: first come first serve, shortest operation time, earliest due date, slack time remaining, last come last serve. They are all priority rules. So I will show you how to calculate this minimum flow time using these priority rules. So are you ready? Okay. So first let's take FCFS. So I'll write here calculation of average lateness. See, although we have not been asked to calculate average lateness, have it calculated. See, all our orders require the use of only color copy machine available. Vision Graphics would like to use the following priority rules and decide the best tool for job sequencing using evaluation criteria of minimum flow time. What you write there, what you write there, you also write, also calculate average delay or lateness in each case. You write there in your notebook. I am asking an additional question. Calculate average delay or lateness. Okay. So let's take FCFS. FCFS. Okay, I'll write here. I'll make a table. I will show you how to make a table. So here it is, job sequence. Then processing time in days. Then you have due date in days. Okay, so I'll write here job sequence. So first come, first serve. So the job sequence is A, B, C, D, correct. Processing time 34261. Due date 56792. ठीक है. Now let me introduce a term, flow time. So what is flow time? You write in your notebook. Flow time is the amount of, I'll write here if you want. Please write in your book. Is the amount of time a job spends in the system. Flow time is the amount of time a job spends in the system. Okay. Okay. So flow time. Now look, this is my first job. So flow time will be how many days? 3 days. Flow time is equal to 3 days. Now for B remains how long in the system? B remains how long in the system? So 3 days plus 4 days, 7 days. See, B remains 7 days in the system because you are going to do A first. You are going to complete A first and then you will take up B, right? So you will need 3 days for A and 4 days for B. So B will spend 7 days in the system. How many days C will spend in the system? Can someone tell me? How many days C will spend in the system? Correct. So 7 plus 2, 9. Then how many days? Okay, correct. So 9 plus 6, 15. And then finally 15 plus 1, 16. See, processing time, if you see, the total is 3 plus 4, 7 plus 2, 9, 9 plus 7, 16. So this should match. This should match. Okay. Now, I will now calculate delay. Also called as lateness in terms of days. Now look, processing time for A is 3 days, but due date is 5 days hence. So can we do A leisurely? Can we do job A leisurely? Because we have 5 days at our disposal and A takes only 3 days. So A can be done leisurely. That means you can delay A little bit. So what is delay? Delay is nothing in case of A. What about B? What about B? Now look at this. The processing time of or mean flow time B will spend 7 days in a system. B is going to spend 7 days in the system. And its due date is 6 days hence. So it should be ready by 8th of November. Today is 2nd of November. Today is 2nd of November. B should be ready by 8th of November. But B is going to remain in the system for 7 days. It will be over by 9th. So there is a delay of 1 day. Correct. I think Aishu Sekhar has got the right answer. 1. What about C? What about C? Please answer, Christopher. I'm talking about C. See, the job is going to remain in the system for 9 days. And due date is 7 days hence. So it is 2, correct. Now what do you think? D will take 15 days to complete. D will remain, yes, Radhika. D will remain 15 days in the system, but its due date is 9 days hence. So it should be ready by 11th. But it will take 15 days. So 6 days of delay. And finally here you have processing time for E is only 1 day, but it will remain in the system for 16 days. So it will be what? So the delay is what? Due date is 2 days hence. And E will remain in the system for 16 days. Anchal has got the right answer. Even Kritika has got right answer. Aishu has got right answer. So I'll write here 14. So let's take the total. And average. So total is what? 50. Here it is 23. Tell me the average. Average is 10, and here it is 4.6. Yeah. Total is 50 and 23 averages. Got it? Good. You calculate average too. Rajesh, that was total. I want you to calculate average. Aishu, Shreyans, they are getting good answers. Good show, good show. Okay. So that was about FCFS. Now let's take the next rule. I hope all of you have written this. Flow time is the amount of time a job spends in the system. Please write it somewhere in the margin. Okay, now next rule. So what is the next rule? Tell me. Next rule is what? SOT. Here the sequence was A, B, C, D. A, B, C, D, and E. What do you think the sequence? SOT means shortest operation time. So you start with the shortest processing time. So can you tell me the sequence if you use SOT rule? So the first job to complete is what? E, because E has the shortest processing time of 1 day. So E followed by C, followed by A, followed by B, followed by D. Okay. So here I will write again job sequence, then processing time, then due date, flow time, and delay. So ECA now you have to pick up the right due data. Please be careful. So 1 and 2. Okay. So flow time is what? Flow time for E2. Then flow time for C is what? Oh, sorry. Flow time for E is 1. Then 1 plus 2, 3. 3 plus 3, 6. 6 plus 4, 10. And 10 plus 6, 60. So this has to be 60. Okay. Can you tell me delay? Okay, Pranav. Why sequence is wrong, Sanil or Pranav? We are talking about SOT, shortest operation time. Shortest operation time. So E has 1, C has 2, A has 3, B has 4, and D has 6. Yes, 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 you're right. You're right. You're right. Yes, Vaibhav, you're right. Yes, yes, yes. I think it was my mistake. It is ECADB. Yes, here I have written correct. Okay. So ECADB, that's right. ECADB. ECAD. ECABD. B is where? Just one moment. B is 4, na? E is 1. Then C is 2. A is 3. B is 4. Now here it is okay. B and then D. Oh. Now it is correct. Yes, Vaibhav? ECABD. ECABD. Okay. So tell me the delay. In this case, delay is what? Dash. Correct. Here the delay is what? See, you have, 7 days at your disposal, and the job is going to stay in the system for 3 days. So delay is nothing. Then here delay is what? 1 day, because the job is going to remain in the system for 6 days and due date is 5 days hence. Here delay is what? 4. Here delay is what? 7. Okay, take the total and average. So total is what? 36 and 12. 7.2 and 2.4. Okay. Now let's take the next one. Rule. EDD. Now earliest due date. Earliest due date. Tell me the sequence. Earliest due date. So what is the earliest due date? It is for E. So tell me the sequence under earliest due date. Bolo. It is E, A, B, C, D. Perfect. Yes, Ranch. Ranch, you have got the right sequence. E, A, B, C, D. Okay, so I'll write here job. Due date. What is due date? Due date is what? Yes, spread out due date. Two, 5, 6, 7, 9. Okay. So flow time 2. 2 plus 3, 5. 5 plus 4, 9. So it is no. It is processing days. You have to take 1. 1 plus 3, 4. 4 plus 4, 8. 8 plus 10. 10 plus 6, 16. See, your processing time should always match with this. Should be always same. Okay, delay bolo. Tell me the delay, correct? Radhika has got the right answer, delay. Okay. So what is this? Total is an average. How much is the total? 39. An average is 7.8. 12 and 2.4. Correct. Anchal has got the right answer. Correct. Okay. Now let's move on to next is what? STR. Okay. Now let me first explain you what is STR. STR means slack time remaining. So it is also called as buffer time. Now see, for A due date is 5 days hence and its processing time is 3 days. So what is the buffer time available? See, look, for A due date is 5 days hence. So you can complete A by 7th of November. But its processing time is only 3 days. So you can do it leisurely by how many days? Correct. Anchal is correct. Radhika is correct. Aishu is correct. You can delay it by 2 days. You can do it leisurely by 2 days. So the buffer time is 2 days. Time at your disposal will be 2 days. So let's calculate buffer time or slack time remaining for all these jobs. So let's calculate. So for A, B, C, D, and E. So tell me for E it is how much? For A it is how much? 5 minus 3. So 2. Then for B it is for C it is for D it is for E it is. Now tell me which is the most urgent and which is the least urgent. Tell me which is the most urgent and which is the least urgent. See, let me tell you, this is the least urgent. And this is the most urgent. See, I can delay C by 5 days, but I can delay E only by 1 day. So E is most urgent, C is least urgent. Okay. Thereafter, we have a tie here, tie. How to break that tie? So for A and B, there is a tie. How to break the tie? So now you check processing time of B and A. So processing time of A is less. See how to break this tie. Check processing time. So processing time of A is less. So you take A first and then B. So what is our sequence? Sequence will be, this is 1, then this is 2, this is 3, this is 4, and this is 5. So how to break that tie between A and B? See, A and B, their slack time remaining is same, buffer time. So buffer time for A and B is same, 2 days. So there is a tie. So how to break that tie? So you check the processing time. The processing time of A is less, therefore A is taken before B. So now the sequence will be job sequence, processing time, then you have due date, flow time, and delay. So job sequence is what? E, A, B, DC. Okay. So fill up the table. Fill up the table. One, 3, 4, 6, and 2. Days 2, 5, 6, 9, 7. So flow time 1, 1 plus 3, 4, 3 plus 4, 7, 7 plus 6, 13. Okay, delay. Delay is what? 0, 0, 2, 5, and 9. Take total and average. Total is 43. This is 16. And this is 8.6 and 3.2. So I hope all of you have understood this. Correct. 8.6 and 3.2. So let's take the next one. Rule. Now this is very easy. Last come, first serve. This is like your LIFO. So it is. So here I'll write A, B, C. Due date is 29765. Flow time. So delay. Very easy. Let's make a summary. Let's make a summary. So particulars. FCFS. SOT. EDD. STR. LCFS. So I'll write here mean flow time. Average delay. Four point 2.4, 2.4, 3.2 and 4. ठीक है? Okay. So mean flow time. Which job? I mean, now see. Which is that sequence leads to lowest mean flow time. Mean flow time means what? The amount of time a job spends in the system. So what do you think? Which is that rule? Which is the rule that leads to the lowest minimum flow, mean flow time? Tell me, what is the sequence or what is the rule which leads to minimum mean flow time? Yes, SOT. And if you use average delay criteria, which is the rule that has lowest average delay. No, I am asking if you use average delay criteria, which rule has the lowest average delay? Again, SOT and EDD. So SOT is more preferable because its minimum average delay is less and minimum flow time. So I'll write here SOT. Since minimum or because of minimum average delay, lateness, and 2 minimum flow time. Okay. So let's take the next problem. Problem number 3. Are you ready? Problem number 3. Are you ready? Problem number 3. Okay. Tree Limited. Let's take this problem number 3. Tree Limited is popular manufacturers of different kind of lifting tools. These lifting tools are made of polypropylene fibers. The company installed a plant for backward integration of its raw material polypropylene fiber. It produces these polypropylene fibers at the rate 5,000 meters per hour. The usage rate of these fiber for production of lifting tool is 20,000 meters per day, considering 8 hours of working per day. The cost of fiber is rupees 5 per meter. Inventory carrying cost is 25% and the setup cost are rupees 4050 per setup. Compute optimal number of cycles required in a year for manufacture of this special fiber. Take 365 days per year for your computation. Please read this problem. Please read this problem. This is problem number 9. Please read the problem. Okay, Brajesh has completed reading the problem. Now, what do you think, Brajesh, this problem is about? This problem is about EBQ, economic batch quantity. Let's try to understand this problem thoroughly. See, I'll read that once again. Problem number 9. All of you, are you listening? Tree Limited is a popular manufacturers of different kinds of lifting tools. Now, what do you mean by lifting tool? Means, let's say crane. Have you seen crane? Yes, you're right. This problem is on EBQ. So lifting tool means, let's say crane, for example. Now these lifting tools are made of polypropylene fibers. So they are made up of fibers. Let's not worry about whether it is polypropylene or simply propylene. It is made up of fiber. Company installed a plant for backward integration of its raw material polypropylene fiber. Now, what do you mean by backward integration? What do you mean by backward integration? Anyone knows what is backward integration? What do you mean by backward integration? Suppose a car manufacturing, there is a car manufacturing company. So this is finished goods. And what is the raw material? Steel, right? Yes, Vaibhav, absolutely right. It is production of raw material. Correct. So there is a car manufacturing company, and suppose this car manufacturing, now car manufacturing company requires steel to manufacture cars. It needs tons of steel. Suppose tomorrow this car manufacturing starts production of even steel, then it is backward integration. Yes, backward integration is when a company buys another company that supplies the products or services needed for production. Absolutely right. Nimi is absolutely right there. So this car manufacturing company, suppose start production of steel, then it is called as backward integration. What is forward integration? What is forward integration? Opposite. What is forward integration? Suppose a company produces fabrics. And let's say it starts producing ready-made garments. Then this is forward integration. Perfect. Again, Vaibhav, you have got it right. We'll move into production of finished goods. So at present, company manufactures fabric, say for example, cotton, terracotta, etc. Now, if it starts manufacturing ready-made garments, then it is forward integration. Okay. Now, in our case, it is backward integration. Now, see what happens. In this case, crane, that is lifting tool, is finished goods. In our case, in the example given, this lifting tool means crane. Crane is a finished product, and its raw material is polypropylene fiber. Now, suppose this company installed a plant for backward integration of its raw material polypropylene fiber. Now, this is backward integration. Have you understood? At present, companies manufacturing lifting tools, but company wants to manufacture fibers. Fibers are raw material for lifting tools. So it is a kind of backward integration. I hope you have understood this. It produces these polypropylene fibers at the rate of 5,000 meter per hour. So that rate is given, which is production rate. The usage rate of this fiber for production of lifting tool is 20,000 meters per day. So that is demand rate, considering 8 hours of working per day. The cost of fiber is rupees 5 per meter. So cost of fiber is given. The inventory carrying cost is 25% and the setup costs are rupees 4050 per setup. Compute optimal number of cycles required in a year for manufacture of this special fiber. Take 365 days. Now see, you all know EOQ. EOQ is for raw material and EBQ is for finished goods or semi-finished goods? EOQ is for raw material. Economic ordering quantity is for purchase of raw material. EBQ is what? Economic batch quantity. It is for finished goods or semi-finished goods. Now look, here you know the formula. What is the formula? 2AO upon C. So A is annual demand. O is ordering cost. And C is carrying cost per unit. Carrying cost of raw material per unit per annum. Now EOQ and EBQ are similar. In case of EBQ, formula is this: 2S upon C, where A is annual demand. What is S? Can someone tell me what is S? What is S? What is S? Under EBQ, what is S? Setup cost. Setup cost per setup. And C is carrying cost of finished goods per unit per annum. Now this is expressed as a percentage of purchase price. This is expressed as a percentage of cost of production. Correct. Renuka is correct. John is correct. So this is annual demand. A is annual demand. S is setup cost per setup. C is carrying cost of finished goods per unit per annum. See actually what happens. Now let me tell you what is setup cost. See, you all know EOQ. I'm not going to explain you what is EOQ. I will explain what is EBQ. What is setup cost. Suppose there are two machines. Machine 1 and machine 2. Now see, in order to make production, in order to produce goods, you need to club the two machines. So this clubbing of machine or coupling, called as coupling also, clubbing of machines is called as setup. So this is preparing machine. This is called as setup. So you cannot go and start machine and produce goods and services. You have to prepare machines for production. So it takes time. It takes labor. So there is cost of preparing machines for production, also called as setup cost. Now raw material enters from this side. And here I have finished goods. Now I'm interested in knowing what is the most economical batch of production quantity, which is A into S upon C. Are you getting that? So raw material enters from this side. So it is processed in these two machines. Now these machines must be combined, must be coupled, must be clubbed. This is called as preparation of machines for production. There is cost of preparing these machines for production and also called as setup cost. So once I process raw material with the help of these two machines, machine 1 and machine 1, I have finished goods at the other end. Now the question is, what should be the economic batch size of this production? But this is when production is without simultaneous consumption. This formula you can use when production is without simultaneous consumption. That means these finished goods you can sell outside. But sometimes this formula changes a bit if we are producing semi-finished goods. So if we have a situation like this, suppose there is assembly line, suppose there is an assembly line and you have to send this finished goods for assembly line, then that is not finished goods, that is semi-finished goods. All of you, have you understood the difference between finished goods and semi-finished goods? Yes, Renuka, have you understood the difference between finished goods and semi-finished goods? Finished goods can be sold in the market immediately, you produce them. Semi-finished goods you send to assembly line first, where they get assembled. Say for example, you are manufacturing tires and tubes. So these tires and tubes will go to assembly line. I am talking about an assembly line of a car. So tires and tubes will be sent to assembly line. So tires and tubes are still semi-finished goods. Okay. For example, steering, or you may say seats. They are all semi-finished product. They should be sent to assembly line, where they will be assembled to produce a car. Okay. Now see, if we have an assembly line, this formula changes. I'll write here. When production with simultaneous consumption. This is called as production with simultaneous consumption. Formula is, anyone knows formula? EBQ is equal to 2AS upon C into 1 minus D by P. When production is so when you manufacture semi-finished goods, the formula changes a bit. Now, what is D and P? You write there D, where D is demand rate and P is production rate. Now, both the rates should be expressed in same units. Please remember this. Both the rates should be expressed in same units. So P demand rate, so D demand rate and P production rate should be expressed in the same unit of measurement. So shall we start? So now with this information, let's see how to calculate EBQ at number of cycles. Look at this. So let's find out okay. So what is A? Tell me what is A? Annual demand. What is A? 20,000 meters per day. Into how many days? 365 days per year. So days gone. And you have annual demand how much? Can you tell me annual demand? Please tell me what is the annual demand for fiber. What is the annual demand for fiber? Anyone? 20,000 into 365 days. So how much is that? 73 lakhs meters per annum. Correct. Achal is correct. Brajesh is correct. VR is correct. Kuldeep is correct. Very good. A good show. Now tell me what is S? What is S? What is setup cost? Setup cost per setup. Correct. Rajesh, Anchal, Vihar, they are all right. Okay. Then what is C? What is C? C is what? Carrying costs of finished goods per unit per annum. What is D? See, now you have a choice. I'll write here D and P. Look what I will do. I'll write here D and P. So you have option 1, option 2, and option 3. See, your unit of measurement should be correct. So this is D is 73 lakhs meters per annum. See this one. This is also equal to D. So if you are taking D per annum, P should be also per annum. So what should be P? Tell me P. P will be 5,000 into 8 into 365, or you may write this as 20,000 meters per day. Or you write 5,000 into 4, or you can write 2,500 per hour. Correct. So this is 1 crore 46 lakhs 000 meters per annum. What do you think this is? You can use any option, any option. Please remember, units of measurements of D and P should be same. Okay, I will use this. I will use this. So my formula will be EBQ is equal to 2AS C into 1 minus D by P. 2 into 73 lakhs into 4050 upon C is what? 1.25 to 1 minus 2,500 upon 5,000. So tell me what is this? Okay, tell me, what is the value? Get me EBQ. See, it is not 14.6 lakhs, it is 146 lakhs. Please remember, those who have written 14.6 lakhs, they are wrong. Correct. Vaibhav has got the right answer. Very good. Very good. So 307 584.13. Please write units. Vaibhav, please write unit. What is the unit? Unit of measurement 307 584.13 meters. Don't simply write 307 584. Please write meters. Okay. So number of cycles per annum. Bolo. Correct. Mageshwar, meters, correct. So number of cycles per annum bolo. See, what is your economic batch size? 3,07,584.13 meters. But what is your annual demand? 73 lakhs. So how many cycles per annum? See, one batch is not enough. One batch is not enough. See, your annual demand is 73 lakhs and your economic batch size is 3,07,584.13 meters. So one batch is not enough. How many batches? How many cycles? Perfect. 23.73. That is approximately 24 cycles. So have you understood? Shall we move on to the next problem? Let's take next problem. That is problem number. So this will be our fourth problem, right? We have completed 3 problems so far. So shall we move on to the next problem? Please tell me yes or no. Yes, yes. 20. Yes, Mageshwar said yes. So 24 cycles is the right answer. We have to prepare 24 batches. So let's move on to, now this will be our fourth problem, right? So let's take problem number. Let's take problem number 4. That means, oh, sorry, problem number 11. Okay. Achal is asking something. See, Achal, it's given there. It produces polypropylene fiber at the rate 5,000 meter per hour of working day. Okay. So that is what the production rate. And you see the usage rate of this fiber for production of lifting tool. Achal, it's given there. See, it produces this polypropylene fiber at the rate 5,000 meter per hour. And the usage of this fiber for production of lifting tool. Lifting tool is finished product. So this polypropylene fiber is a semi-finished product. So as soon as you produce fiber, it will go to lifting tool department. Are you getting, Achal? Okay, Achal has got it. Fine. Now let's try the next problem. So which problem is that? How many problems we have solved so far? 3, no? So next you take problem number 11. Okay, good. Achal has understood, fine. So let's take problem number 11. That is our fourth problem for today. Chalo. I will read that problem. The following table gives the running cost per year and resale values of a certain equipment whose purchase price is 6,500. In which year the replacement is due optimally. So year is given 1, 2, 3, 4, 5, 6, 7. Running cost is given and resale value is also given. Resale value means scrap value. Now you read this problem once. Please read this problem. Let me know if you have completed reading. Okay, Bala has completed the first reading. Now see, let me tell you, this is a problem on replacement. Yes, Pooja has completed. This is a problem on replacement. Now let's see the idea behind replacement. See, all industrial equipments, they get worn out over a period of time due to usage. So this wear and tear over passage of time leads to a reduction in efficiency and increase in maintenance costs. See what happens. Industrial equipments like machines, trucks, cars, they get worn out over a period of time due to usage. Now this wear and tear over a passage of time leads to what? Leads to two things: a reduction in efficiency and an increase in maintenance cost. Suppose you purchase a brand new bike. Initially, average is great and maintenance cost is negligible. But as the time progresses, average mileage becomes less and less. So its efficiency falls. And maintenance cost, which is negligible today, starts rising. So these two things, drop in mileage, a drop in mileage and an increase in maintenance cost, leads to replacement situation. So you will think of now replacing this bike with some new bike. So that is what the idea behind replacement. Now, what is the objective? Objective here is to understand in which year we should replace the existing machine or a car or a two-wheeler or an equipment. So obviously this decision is called as ORP. To find out ORP. So in which year this machine should be replaced? In which year a two-wheeler should be replaced? And what is the criteria we use? We use cost. Depends on average cost per annum. Now, average cost is what? It is the total cost per annum divided by number of years. Now, what is total cost? Total cost will be capital cost. That means purchasing price. Net of scrap value plus cumulative maintenance Okay. Now let me explain you once again. So what is that we said? All industrial equipments, they get worn out over a period of time due to usage. This wear and tear leads to two things: a reduction in efficiency and increase in maintenance costs. Both these factors will necessitate the replacement of the existing machine with a new machine. Okay. Now, what is the decision that we take normally? The decision to be taken is in which year the machine should be replaced, which is called as optimum replacement period, ORP. Now it depends on what? It depends on average cost per annum. Now average cost is further dependent on total cost per annum. Now what is total cost? Total cost is this: purchase price net of scrap value or salvage value plus cumulative maintenance cost. So this formula of average cost will be something like this. Total cost upon number of years. Now total cost, as we rightly said, it is C, capital cost minus scrap value in year R plus summation I goes from 1 to R empty. Now you would ask me, what is R? Now R means the year in which you are replacing the machine. R means a year in which you are replacing the machine. So SR, scrap value, suppose I want to replace a machine in 6th year. So SR means scrap value in the 6th year, and maintenance cost up to 6th year. So that I goes from 1 to R means I will add up the maintenance cost from year 1 to year 6, and then I will divide it by number of years. So let's calculate this average cost in this case. Ready? So let's make columns. So right here, calculation of optimum replacement period. So here I have year, then capital cost, which is in terms of rupees. Then you have salvage value. Yes. So net capital cost so C minus S. Then you have maintenance cost. cumulative maintenance cost, cumulative maintenance cost. So this is your summation M. Okay. Then you have total cost, and then you have average cost. So you make a table like this. Please make a table like this. So this here you write R, here R. Okay. So here I'll write 1, 2, 3, 4. One, 2, 3, 5, 6, 7, 8. Okay. So capital cost. Now see, these are all, alternatives. They are competing with each other. What I am checking is, what if I replace this particular equipment at the end of first year, that I am comparing with what if I replace it at the end of second year, which I am comparing with what if I replace it at the end of third year, and so on. So all these alternatives are competing with each other. So we are checking, what if we replace it at the end of first year, what if we replace it at the end of second year, what if we replace it at the end of third year, and so on. And then we'll check the average cost. And where the average cost is lowest, that will be our ORP. So let's write here 6500. Okay, I'll write salvage value here. Salvage value is 4,000, 3,000, 2,200, 1,700, 1,300. So value, net capital cost, 61. Sorry, this is net capital cost is what? 2,500, 3,500, 4,300, 4,800, 200. Okay. So maintenance cost 1400. So this is 1400, 2900, 4600, 6600. Correct. Parag. Pranav has got the right answer. Nine thousand, 11,800, 15,100, and 1,900. So total cost. Tell me the total cost. Anyone? Anyone who has calculated total cost? Please give me the total cost fast. See, if you want, I will write the column numbers. So this is 1. This is 2. Okay. So what I'll do is C minus S. So this is 1. This is 2. This is 3. This is 4. 5. 6. 7 is 4 plus 6. And this is 8. Okay. So total cost 3,900. Yes, Aishu. Yes, got it. So 3,900, 6,400. See, give me the numbers. Average cost. $3,900, 3,200, 2,967. So tell me, which is the least average cost here? Which is the least average cost? Yes, Sanil Patel has got the answer. Look at this. This is the least. So that represents ORP. So in which year it is? In which year it is? Fifth year, na? 1, 2, 3, 4, 5. Fifth year, yes. Vaibhav has got the answer. So right here the answer. The machine should be replaced. At the end of fifth year. Since average cost is minimum. Correct. Pranav, Ravi, Kuldeep, Aishu, Vaibhav, they have all got the right answer. Wonderful. Congratulations. So shall we move on to the next problem? Shall we proceed to the next problem? Shall we proceed to the next problem? Okay. So let's take number. Let's take number 5. That means problem number 7. In our case, it is problem number 7. We are going to solve fifth problem for today, which is problem number 7. A public transportation system is experiencing the following number of breakdowns for months over the past 2 years in their view, in their new fleet of vehicles. Now fleet means group. So in their group of vehicles. So number of breakdowns 0, 1, 2, 3, 4. Number of months this occurred 2, 8, 10, 3, 1. Each breakdown cost the firm an average of rupees 2,800 or a cost of rupees 1,500 per month. Preventive maintenance can be carried out to limit the breakdowns to an average 1 per month. Which policy is suitable for the firm? Please read this problem and then we'll solve it. So problem number 7. Okay, great. Arti, Brajesh, Vaibhav have They have all completed reading. So now this problem is on what? Maintenance management. Now see, they have given you number of breakdowns and the frequencies. Can we calculate probabilities? I will show you how. See, I'll write here calculation of expected breakdown per month. See what I will do, I'll write here number of breakdowns per month then number of months this occurred. So in a way it is frequency. This is called as frequency. So for example, see in 2 years, only twice there were no breakdowns. So in last 24 months, 2 months were without any breakdowns. So here it is 0 and frequency is 2. Total is 24. Now I will show you how to calculate probability. See, here I'll write probability. Now see, 2 out of 24 times in the last 2 years, number of breakdowns were 0. So may I ask you, what is the probability that number of breakdowns would be 0 in future? So probability will be 2 by 24. Try to understand this. See, suppose we want to calculate probability that India wins a test match against Australia. So what we'll do, we'll check all the test matches played between these two countries. Let's say 200 test matches are played between these two countries and 40 matches have been won by India. So what is the probability that India wins a test match against Australia 1 by 5? 20%, 0.2. So likewise here it is, probability is 0.083, correct. This will be 8 by 24. So what is that? Yes, I think Ravi Kumawat has already computed them, 0.333. So I will just copy his numbers, 0.417, that's right. Then 0.15 and point बोलो 0.42 क्या? What is it? So total probability should be 1. Okay. Now next what I will calculate is expected value. Now let me explain you what is expected value. See, expected value is average, nothing else. Expected value is average. And how to calculate expected value? Average, because it is average, I say it is x bar. How it is calculated? Summation p into x. Now let me explain you this. Suppose there is an analyst. There is an analyst who says that if economy is good, for which there is 70% chance, 70% chance means what? Probability is 0.7. Then revenue will be rupees 100 lakhs. But suppose economy turns out to be bad, for which there is remaining 30% chance, then the revenue will be as low as 50 lakhs. Can you tell me average or expected value of this? Can you tell me expected revenue? Can you tell me expected revenue? See what I do. This is my X. I'll show you how to do. This is my X. Sorry, this is my X. And this is my P. So what I'm doing is I'm taking the product of these two, P into X. So 0.7 into 100, which is 70. And this is 0.3 into 50. This is 15. So summation of P into X is 85. So expected revenue will be summation P into X. So rupees 85 lakhs. 85, yes, Sunil is correct. Vaibhav is correct. So expected revenue will be 85 lakhs. That is average revenue. Now see these two figures, 100 and 50, they stay close to 85. So 85 is your central figure. 85 is called as central tendency of the data. So average of the data. So sometimes revenue will be more than this. Sometimes revenue will be less than this. But on an average, revenue will be 85 lakhs. Having understood the concept of expected value, let's calculate expected value here. But what is expected value in our case? That will be expected number of breakdowns per month. See, here it is. This is what our X is. This is what our probability is. So let's calculate P into X. Bolo. P into X. Please calculate P into X. So this will be 0. Please get me P into X. Correct. Brajesh, yes, you're right. So this will be 0.834. And this will be 0.167. So tell me what is total. What is total? Okay, 1.710. Now what is it actually? It is expected. See, look at this. Expected breakdown. $1.71. That is 1.71 on an average. I'll write here. Means on an average 1.7 breakdown per month. in 1 month. Correct. Now look. Now suppose now we have two options. Let's explore these two options. What if we carry out preventive maintenance, and what if we don't carry out preventive maintenance? So my first policy is something like this. No preventive maintenance is carried out. No preventive maintenance is carried out. Okay. Now I have to calculate breakdown maintenance cost per month. Can someone tell me what is it? In that case, yes, correct. It is 1.71 into 2800. See, what does that mean? That means we wait for a breakdown to occur and then we carry out breakdown maintenance. See, meaning is we wait for a breakdown to occur, and once the breakdown occurs, we'll carry out breakdown maintenance. We don't carry out preventive maintenance at all. We don't carry out preventive maintenance at all in policy 1. What it says, no preventive maintenance is carried out. So what do? We wait till a breakdown takes place, and once the breakdown takes place, we carry out breakdown maintenance, which costs rupees 2800 per what breakdown, right? So that cost is given. Each breakdown costs the firm on an average 2800. So meaning is we wait till a breakdown to occur, and then we carry out rupees 2800. So this will be rupees. Okay. So what I will do, I'll write here 1.71 breakdown per month into rupees 2800 per breakdown. Now see my breakdown gone, leaving there what? Kon sange? Who is so 2800 into 1.71. So 4788, correct. Now policy 2, what policy 2 says? What policy 2 says? What policy 2 says is preventive maintenance is carried out. Now see, if you carry out preventive maintenance, what happens? You have to bear that preventive maintenance cost. So what is it? Now I will calculate all costs per month basis. Huh? So this is per month basis. Please write here per month. Huh? So this cost is per month. So 4788 per month. This also I will calculate per month basis. So what is preventive maintenance cost per month? Who can tell me? How much is that? Yes, Sanil, you're right. It is 1500 per month. Okay. Now see what happens. If you carry out, listen now, please. If you carry out, correct, Brajesh, you're right. If you carry out preventive maintenance, then your breakdowns will reduce from 1.71 to 1 per month. All of you, are you listening? If you carry out preventive maintenance, then your breakdowns will reduce from 1.71 per month to 1 per month. Have you followed this? So you add to that breakdown cost per month. Okay. Now this is 2800. So I'll write here a note. Will reduce so you may say this is 2800. So total cost per month. So which policy is better? So which policy is better? What do you think? Which policy is better? Hence, preventive maintenance policy is suitable for the firm. In that case, its total cost is minimum. This is our policy 1. This is policy 2. Okay. There is a query from Mageshwar. See Mageshwar. All of you, listen to his query. What he says, Mageshwar, how breakdowns, they will reduce from 1.71 to 1. See Mageshwar, what happens? Suppose we wait till a breakdown to occur. And once the breakdown occurs, we take up the breakdown maintenance. Then there will be 1.71 such breakdowns. So you may say 2 breakdowns in a month. See, we don't carry out in any preventive maintenance. What happens is we allow a breakdown to occur. And once the breakdown occurs, we carry out breakdown maintenance. But in that case, there will be almost 2 breakdowns per month, 1.71 breakdowns per month. But suppose we carry out preventive maintenance costs, then the breakdowns will reduce from 2 to 1, or you may say 1.71 to 1, because we are carrying out preventive maintenance cost. Now, let's say you have a bike at home, you carry out preventive maintenance every quarter. Every quarter you send your bike to your mechanic, so there will not be any breakdown, major breakdown in future. So same thing happens here too. So if you carry out preventive maintenance, then you don't have to worry about breakdowns as such. So breakdowns will come down from 1.71 to 1. Yes. Okay, great. Yes, Anil Patel is correct, due to preventive measures. Yes. So in this case, our policy 2 is good. So shall we proceed to the next problem? This will be our problem number 6. Problem number 6. So this problem number 6 is actually problem number 3. So let's calculate problem number 3. Now let's calculate the answer to problem number 3. Now this is our 6th problem for today. Okay, good. So let's read that problem. Let's read that problem. A work operation consisting of 3 elements has been subjected to a stopwatch time study. The raw data are contained in the following table. So you have job element 1, 2, 3, performance rating 90%, 100%, and 120%. Observations minute per part, cycles. So 1, 2, 3, 4, 5 cycles. So these are the observations which are given. Find normal time for the operation and standard time for job if total allowance are 15%. So please read this problem once. Okay, Pranav has completed. See, basically here we want to calculate standard time. Right there, calculation of standard time. See, this is a part of your work measurements. So you remember, in costing we use terms like standard time for job A is 10 hours, or it is 5 minutes, or it is 2 hours, or 3.5 hours. When we do topics like labor, we come across these words, the standard time for job XYZ is 5 hours, etc., etc. Now, in this case, we are going to actually calculate the standard time of this particular job. See, what is the benefit of computing standard time? Then it will be acceptable to workers and therefore labor union. Say for example, standard time you calculate and is acceptable to workers. Then see what happens. You can easily calculate labor cost per unit. Say for example, standard time is 20 minutes you calculate, and which is acceptable to the labor union, and the rate is, let's say, rupees 100 per hour. So what do you think? That's labor cost for that particular job. Standard time acceptable or standard time calculated is 20 minutes, which is calculated using this stopwatch time study. It is called as stopwatch time study and is acceptable to the labor or labor union. And let's say labor rate is rupees 100 per hour. So what do you think? Labor cost per unit. So 100 divided by 5, rupees 100. See, 20 minutes is standard time. So that is 1/3 hour. And labor rate is, let's say, rupees 100 per hour. So what is labor cost per unit? Is rupees 100 per hour into 1/3 hour per unit. So what is that? Rupees 33.33 per unit. So all of you, have you understood the importance of computing standard time? So let's see how to calculate standard time. Let me tell you first, we calculate observed time. We call it as OT. Then we adjust it with performance rating of worker. So we get normal time. So normal time is observed time into PR. Okay. Then once we calculate normal time, we adjust it for allowance. So now, and we call it as standard time. Which is called as ST. Now ST has two formulas. ST is equal to normal time upon 1 minus A. Allowance is A. And this is ST is equal to normal time into 1 plus A. Okay. So this is how we calculate standard time. Now what is PR? What is PR? PR means performance rating. So if performance rating is 100, then that worker is a normal worker. If performance rating is 120%, then he is a fast worker. If performance rating is 90%, then he is a slow worker. So suppose fast worker does a job in 10 minutes, then normal worker will take longer or shorter? Bolo. If a fast worker does a job in 10 minutes, then a normal worker will take longer or shorter? The normal worker will take longer because fast worker needs 10 minutes. So normal worker will require 12 minutes. So that is what the significance of performance rating. That means actually it is efficiency. No, Anchal, it is longer. See what I said, we have a fast worker. Let's say his performance rating is 120%. He completes a job in 10 minutes. So any worker, any normal worker will take longer or shorter? Obviously longer. Yes. And suppose we have a slow worker. Let's say his efficiency is 90%, performance rating is 90%. He completes a job in 1 hour. So normal worker will do it sooner or later. See, a slow worker makes a job in 1 hour. So a normal worker will take longer or shorter. Sooner, yes. See, suppose a slow worker needs 1 hour, then a normal worker will need, 0.75 hour or zero point 0.8 hour, or let's say 45 minutes. Slow worker takes 1 hour. So normal worker will require 45 minutes, 40 minutes. Okay, good. So this is what the concept of performance rating. Now this observed time, which is nothing but average time. Please remember, observed time is average time. So observed time is based on average time. You adjust with performance rating of the worker, you will get normal time. And normal time you adjust with allowance. Now what is allowance? What do you mean by allowance? Allowance means personal delays. Say for example, workers, they may go for having a glass of water, or they may go to restroom, or sometimes there are unavoidable delays like waiting for material, then there will be machine adjustments. So you can't avoid them. You can't help. You have to give certain allowances to workers because they take routine breaks. Say for example, they go to restroom, then they go for a glass of water, or sometimes there could be unavoidable delays like waiting for material, or sometimes some machine adjustments are required. So these allowances are given. In that case, we have two formulas. This formula is used when A is expressed as a percent of standard time allowance, and this formula is used when A is expressed as a percent of normal time. See, this formula is more common. This formula is more common. So let's solve this problem. So now you go through the data. You go through the data and tell me, do you think any of the observation could be wrong or could be an error? Go through those cycles 1, 2, 3, 4, 5 of 90%, 100% and 120% PR rated workers. Go through that data and just check whether there is any error of observation. Please check. Go through that data and check whether there is an error. See, there are 3 workers. One is with 90% PR, the other with 100% PR, and third is with 120% PR. Please check whether there is any error of observation. Please check. See, job element, all of you check this. Job, Bala, there is an error. There is an error. See, I will show you which is that. You check job element 3 Bala and cycle number 3. See, otherwise observations are 0.15, 0.14, 0.16, 0.16. But that observation is 0.39 minutes per part. Bala. Job element 3 and cycle number 3. See, time is 0.39 minutes per unit. This is an error. Yes, error occurred. 90% take much time. No. See. This job element 3 is done by, see, look, all of you. I think Ravi has not understood. See, job element 1 is done by a worker whose PR is 90%. Job element 2 is done by a worker whose PR is 100%. Job element 3 is done by a worker whose PR is 120%. So I'm talking about the same worker. You check the last row, 0.15, 0.14, and suddenly 0.39. So it's an error. It's an error while observing that worker. It is a stopwatch time method. You can go through the module to understand what is stopwatch time method. So this is an error. This 0.39 is an outlier. It will change the entire standard time. So we have to exclude this. So I'll write here time 0.39 minutes per unit. This is an outlier. You understand the meaning of outlier? Outlier means one that lies out of the range. So 0.39 is out of the range. This is an outlier. Means a probable error in reading or recording. Recording data. That should not be included. That should not be included in analysis. That should not be included in analysis. Now see, what is the first thing we have to calculate? We have to calculate observed time, which is an average. Once we calculate average, we have to adjust it for PR. And once we adjust it for PR, next step is we have to adjust it for allowance. So let's do it. So you make a table like this: job, then average time, which is actually, or here I'll write observed time, then PR, and I have normal time. Now NT is equal to OT into PR. So job 1, 2, 3. Based on average. So calculate average 0.15 plus 0.18 plus 0.17 plus 0.16 plus 0.19 divided by 5. Tell me what is it. Please tell me what is it. Please tell me what is it? 0.15 plus 0.18 plus 0.17 plus 0.16 plus 0.19. Then here next 0.22 plus 0.23 plus 0.24 plus 0.22 plus 0.24 divided by 5. Okay, so this is 0.17, correct. This is what? The next is 0.20. What is it? Please tell me what is that. So next is 0.15 plus 0.14. You discard 0.39. 0.16 plus 0.16. Discard that outlier. Exclude. So 0.23. And you exclude that outlier and tell me the average. Point 15. Okay. So tell me what is the PR. So PR here is 90%. This is 100%. And this is 120%. So can you tell me normal time? Now this 0.17 minutes per part is by a slow worker. So normal worker will take longer or sooner? Correct. So 0.17 into 90%. So 0.15. Let's take up to 2 decimals. This will be 0.23. Same. 0.23 into 100%. And this will be 0.15 into 120%. So what is that? 0.18. So total normal time. So total normal time is what? Point. Chalo, total normal time. 0.56, correct. See, Harika, job element 2 and job element 1 are totally different. Job element 1 is different, job element 2 is different. Job element 1 is done by, let's say, worker X. Job element 2 is done by worker Y. Job element 3 is done by worker Z. So you cannot compare them. You can compare the cycles 1, 2, 3, 4, 5 and not the job element. So this is 0.56. Okay. So now normal time of operations is equal to 0.56 minutes. Now standard time, what is the formula? Can someone tell me standard time formula? ST is equal to NT upon 1 minus A. So NT is equal to 0.56. One minus 0.15. Now they have not said कि allowance is expressed as a percentage of standard time or allowance is expressed as a percentage of normal time. Normally we take what? Allowance as a percentage of standard time. So this formula we use normally. if data not given. So what is this? 0.66. So how much is that? 0.66 minutes. Therefore, standard time of job is 0.66 minutes per unit. Okay, good. So let's do the last one for today and then we'll stop. Let's take one more on work measurement. Shall we? Can we proceed? See, another 10-15 minutes and half the number of problems will be over. So are you ready or tired? So we'll take one more and then we'll stop. So let's take problem number 4. Let's take problem number 4. We'll take one more and then we'll stop. This is again a problem on work measurements. Only this time we use another method which is called as work sampling. So let me read this question. Okay. The work study engineer carries out the work sampling study in a machine shop for a duration of 120 hours. The following observations were made for a machine shop. Total number of observations 7,000. No working activities 1,200. See that that is not number. Huh? It is not number of working activities. No working, that means idle. So you can cancel that. Full stop. Ratio between manual to machine element 2:1. Average rating factor 120%. That means PR of the worker. Total number of jobs produced during study 800 units. Rest and personal allowance 17%. Compute the standard time for the job. Please read this question. This is an important question. It was asked so many times. All these questions that we are doing, they are important, but this is more important. Okay. Kritika has completed reading. See, this method is called as stopwatch time study method. See, earlier method is called as stopwatch time study. So SWTS. Now again, we are computing standard time, but using work sampling. Also called as activity sampling. So this is another method. This is another method for computing standard time per unit. The earlier method is called as stopwatch time study. See, let me tell you, this sampling, work sampling or activity sampling is very important as far as your exam goes. So let's do this problem and then we'll stop today. Okay. Now see, I will show you how to do it. See, activity level, I'll write here. As per sampling study, activity level as per sampling study is, see, basically 7,000 minus no working act. Okay. This is ideal. So that is below 5,000 minus 1,200 divided by 5,000. So how much is that? So what is it? See, that no working activity you write as no means that full stop is not required. That is redundant. That is extra. So that is 0.76. Okay. Now activity working time. That is productive time in duration of of in duration of 120 hours. Now you tell me. Now you tell me. Oh, sorry. No. This is 7,000. No. Nishal. It is. It's my mistake. My mistake. 7,000. It is 7,000. Sorry. 7,000. Good that you have noticed. Nishal Mageshwar. You are right. This is 7,000, not 5,000. You are right. So my mistake. So tell me 7,000. Yes, you are right, Nishal. 7,000. It should be 7,000, Nishal. So 7,000 minus 1,200. 5,800. Yes. So this will be 5,800 divided by 7,000. So how much is that? Yes, you are right. Nishal is correct. It is 7,000. So what is the percentage? Bolo jara. See, 5,800 divided by 7,000. It is 82.8286. That is 82.86%. Okay. Now see, significance is, what is the significance of this? 82.86% of the time you are productive, and remaining 17.14% of the time you are idle. See, all of you, check this. Total number of observations are 7,000. Out of that, idle or no working activities are 1,200. So what happens is 82.86% of the time you are productive. You are not idle. So activity working time, that is productive time in duration of 120 hours, who can tell me, is equal to 82.86% of 120 hours. See, I will explain. See, out of 7,000 times, you are idle for 1,200 times. That means you are active for how many times? 5800. So 83% of the time you are active and 17% of the time you are idle. Have you understood? Yes, Nishal? Now is it okay? See, 83% of the time you are active. No, Vaibhav, it's wrong. It is not 93.43. So 83% of the time you are productive, but remaining 17% of the time you are idle. Are we all together? Are we all together? No. Nishal has got it. Brajesh has got it. I think Sanil and Vaibhav, they are getting wrong results. 99.43. Why 99.43? Why others are getting 99.6%? See, you should get 83.86%. Okay. So now, see, 83% you are productive and 17% you are idle. So if you work for 120 hours, how long you will be productive? You tell me. So this is your productive time. So how much is that? Yes. So 82 point into 120. So that gives me 99.43 hours. So this is what my productive time. Now productive time leads to production. Oh, I see. Okay. Yeah. Okay. I think, yes. No, yes. These people are right, I think. Okay. What I thought was they are saying percentage. Yes. I think Ravi, Kumawat, Vaibhav, Sanil Patel, yes, they are all right. Okay. So I thought they are talking about percentage. No. But they should write their this thing, no, unit of measurement. Had they written their hour, I would have easily understood. Okay. Now see, can I write 99.43 hours of productive time will lead to how many units? 800 units. .43 hours, because this is productive time. This is your productive time. And this is your production. So 1 unit will take how long? Bolo. 1 unit will take how long?
Hello.
1 unit will take how long? Point 12 hours. हाँ पूजा. 1 unit will take how long? 0.12 hours. So how many minutes? How many minutes? Okay. Please give me the answers so that we can complete that fast. I'm not getting any answers. Okay. Now this has got two components. Manual labor time for which PR is applicable. And machine time per unit. No PR is applicable. So what is that? 2:1 manual. So this is 2/3 into what? 7.46. This is 1/3 into 7.46. Tell me what is this? .46 into 2/3. 4.97 minutes. $2.49. Yes. Okay. Now this is what my OT is. So right here, observe time. Observe time OT of worker. So normal time will be what? OT into PR, but this worker is fast. This worker is fast. Please remember this worker is fast. So it will take longer or sooner for a normal worker to do the same job. So 4.97 into 120%. It will take longer for a normal worker to do this job. So how much is that? 4.97 into 120%. So 5.96 minutes per unit. Now standard time. Standard time again. No, Vaibhav. For a normal worker, see, this worker is fast. So suppose he completes a job in 1 hour. The normal worker will take 1.5 hours. Na? Normal time is the time by normal worker. Christopher, Ravi, please check. See, he is a fast worker. How do you know he is a fast worker? His performance rating is 120%. He can do that job in 4.97 minutes. But a normal worker will take more. A normal worker will take 5.96 minutes. He will take more. Na? He will take longer. So ST, now standard time. So nothing is mentioned here. Huh? Common formula. So what is standard time? Bolo jara. Standard time will be normal time. Normal time is what? 5.96 minus 5.96 divided by 1 minus 0.70. So how much is that? Okay, 7.18. Okay, minutes per unit. But please remember, this is only manual time. Total standard time, you have to add machine time too. So 7.18 plus the earlier machine time was how much? 2.49. How much is this? Please add that machine time. $9.67 minutes per unit. Yes. So right here. Okay. So I think this is where we have completed 7 problems. So we are midway. Tomorrow we'll solve some more problems. But if you can do them once at home, then nothing like it. They will help you immensely in the exam. So that is how we are doing revisions. I am going to take only numerical problems. theory you can read, from the module. You can also do objective type questions. So I will give stress more on problem solving. So tomorrow also we'll solve questions on transportation, assignment, project management, linear programming, important topics I will cover tomorrow. These are also important, but some more important topics I will cover tomorrow. So I think we should now give control to Manjari sir or Virak Shah sir.
Yes. Thank you, sir.
Welcome sir.
Thank you very much.
So now if they have any queries, they can ask me. Or if they are tired, then we'll take query session tomorrow.
Okay, sir.
You can. Okay, thanks a lot. Thanks a lot to you all. If you participate, then it will be more and more, pleasant. So it will not be tiring, provided you are participating. Thank you very much to all of you. Yes, Pooja, I could see you. Then others also. So do you have any sheet or formulas so that we can quickly revise for them? Actually, formulas, I don't have any sheet, but let me check. So we'll meet tomorrow. Manjari sir.
Yes, sir.
काय करायचं? काही मुलांना आहे का, म्हणजे काही त्यांना अनम्यूट करा ना, म्हणजे त्यांना विचारते. सो इफ यू कॅन अनम्यूट or thank you very much, you liked it. So tomorrow also be present. We'll be doing some more important topics. Okay, I think if they have no queries, then we shall call it a day. Yes, Sanil, I have gone through last 5-6 papers. I think such questions will be asked. But see, these are all, I mean, this is just a revision, but it will definitely give you some age, So I think we should stop. हा सर, काय करायचं?
Hello, sir. Hello. Sir, we will discuss tomorrow.
Okay. So I will sign off, sir. Okay, all of you, best of luck. Do come tomorrow.
Please.
Yeah. Okay, bye.
Thank you, sir.
Bye.